Ready for a deep dive into the future of farming. We're talking smart farms and AI, specifically how accurately we can predict something like tomato yields.
Yeah, it's pretty amazing. Using data to bring insights to something as, old as agriculture. Like, we might be on the edge of a farming revolution here.
And we've got a recent master's thesis, a study on model optimization for predicting tomato yield in Smart Farm Greenhouse by Jinman that takes us right to the heart of it.
And this isn't just theoretical stuff, this is based on a real-world competition they had in a South Korean smart farm.
It's really interesting they had access to all that data, a constant stream from a real live working greenhouse, temperature, humidity, CO2 levels, even how conductive the nutrient solution was.
A goldmine of data. And this researcher put 3 different AI approaches to the test, like high-tech prediction engines.
I like that. Prediction engines. Okay, so lay it on me. What are these AI engines?
Okay, so one was the random forest model. And the way that works is it's kind of like getting predictions from a whole forest of decision trees.
Okay, so like a wisdom of the crowds approach, but with algorithms.
Yeah, exactly. And then there's LSTM, which is the neural network that can understand patterns as they change over time, which is perfect for, a greenhouse environment, which is always changing.
Yeah, makes sense. Things in the greenhouse are definitely in flux.
Right. And then finally we have GRU, and that's a kind of simplified version of LSTM. It can be useful when you have, smaller data sets, which you often do in agricultural research.
So I'm going to ask the obvious question. With all those fancy models, which one was the most accurate?
And this is what's really interesting. You'd think the most complex model would be the most accurate, but in this case, the simpler random forest model, that was the winner. And get this, it achieved that high accuracy using just 3 key factors.
Just 3. Out of all that data, okay, you're going to have to tell me, which 3 are we talking about?
The winning trifecta: internal CO2 concentration, the amount of solar radiation, and no surprise, internal temperature.
Okay, so instead of drowning in a sea of data, focusing on just a few key measurements, you actually get the best results. Fascinating.
Yeah, and it points to a larger question about smart farming.
Yeah.
What are the essential data points to focus on?
Yeah.
And what technologies can monitor and control them? It might be a shift from collecting everything to collecting smart.
Okay, so just a few key measurements, and that seems to be the winning strategy. But isn't it interesting, all the models, even the more complex ones, they all landed on those same 3 factors: CO2, light, and temperature. It's like the holy trinity of growing tomatoes.
It really is. I mean, it makes sense when you think about it, right? You've got CO2, that's like the building block of photosynthesis.
Yeah.
Solar radiation, that provides the energy to make it all happen. And then temperature, well, that's like the catalyst, speeds the whole process up.
Yeah, it's like baking a cake. You need all the right ingredients in the right amounts in the oven at the right temperature.
Perfect analogy. And this is where it gets really exciting for farmers. Imagine being able to optimize those 3 factors so precisely. Instead of just reacting to the weather, they could be proactive, really nudge those tomato plants into overdrive.
Right, from hoping for the best to knowing they're set up for a bumper crop. It's really interesting, this whole idea of moving from reactive to proactive. But speaking of insights, I understand this thesis also had some unexpected findings. It wasn't all, smooth sailing.
Yeah, you're right. And this is where it gets even more interesting. The researcher found that just throwing more data at the AI models, it didn't always lead to better predictions. Sometimes it actually made them less accurate.
So it's not just how much data you collect, it's the type of data, the quality of the data. It's about being more selective.
Exactly. This research shows how important it is to really understand your data and how those AI models use it. It's like having a state-of-the-art kitchen, but you don't know the difference between baking soda and baking powder. Might end up with a disaster instead of a delicious cake.
You need the right ingredients, and you need to know how to use them.
Okay, so this is all fascinating, but for those of us who aren't tomato farmers, what's the takeaway here?
That's a great question. And it takes us beyond the greenhouse. We're getting into a much broader conversation about the role of AI in our lives.
So stepping out of the greenhouse into the bigger picture,
Yeah.
AI in our lives. What's the big takeaway?
Well, this research really drives home the point that more data isn't always, the answer. It's not always better. We're practically drowning in data these days. But this study reminds us that we've got to be smart about it. Smart about what we collect and how we use it.
Discerning, not drowning. Choosing quality over quantity.
Exactly. AI isn't like, some magic solution. It's a tool. And like any tool, it's got its limitations. We still need, human knowledge, human experience to really make sense of all that data, to make sure we're using these powerful technologies the right way.
Yeah, it's like having a super fast car. Doesn't matter how great the car is if you don't know how to drive the darn thing right. Exactly. And it kind of brings us back to that thought the researcher had at the end of the thesis. Remember how we were talking about those 3 environmental factors? What if we could, bring even more information to the table?
You're talking about going beyond just the environment, like looking at the tomato plants themselves.
Yeah, exactly. What if we could factor in their growth rate, leaf size, even the color of the plants? Can you imagine the level of insight we could get combining all that information?
Almost like you're getting a behind-the-scenes look at how those plants are reacting to the environment in real time. You could see what's working, what's not, and really fine-tune things.
Exactly. It's a really fascinating avenue for future research. And I think a perfect example of how this deep dive has really only scratched the surface. There's just so much more to discover when you combine things like AI, agriculture, and just good old-fashioned human curiosity.
And on that note, we'll leave you with this. As we keep venturing into this world of, AI-driven agriculture, what other discoveries are out there? What other connections are waiting to be uncovered? Until next time, keep asking those questions, keep diving deep, and keep exploring this incredible world around us.